Okay, year 11, we're looking at parallel and perpendicular lines. Again, we'll just go through examples. So parallel lines never meet, have the same gradient, and obviously the y-intercept will change. And with perpendicular gradients, the relationship between the two gradients is that when you multiply the two gradients, m1 and m2, you get the product of -1. So copy that down, and when you're ready, come to the next slide. So we're just going to work through examples of parallel gradients and perpendicular gradient questions in gradient intercept form and general form. So just follow through. Let's just have a look. So find the equation of the line parallel to y equals 2x minus 3 passing through the point 4 minus 7. So over on this side here, I've got a diagram. There's the original line 2x minus 3. It has a positive gradient. It goes through the y-intercept as -3. And I've got a point 4 minus 7, which is somewhere down here. And so we've got another line parallel to it. So we're expecting to get a y-intercept less than -3. Okay, so if they're parallel, the gradient is 2. Where do we get that number from? It's just the coefficient there. So if it's parallel, it has to have the same gradient. So all it is, it's going to be a new equation, and all we're going to do is just find the new value of the y-intercept. And how we find that, we just plug the values of y and x, and the b value will be evaluated that way. So put the y and the x in the equation, simplify. The 8 has to go across the other side to isolate the b, so it becomes -8. -7 minus 8 is -15. And so the new equation is 2x minus 15. So copy that in, and when you're ready, come to the next slide. Okay, so the same sort of question, but the line is in general form rather than in gradient intercept form. So it's the same sort of wording, just changing how it looks like at the start. So if they're parallel, the gradient is the same. Now you don't actually have to work out, like for instance, 3y would be -2x plus 7, and y equals -2/3 x plus 7. So you don't actually have to tell me that the gradient is -3. If it's parallel, it's still going to be of the form 2x plus 3y, and all we're doing is working out a new value over here. Now obviously I've just made a slight error there. That should be 7 on 3. So that's the y-intercept. Okay, 7 on 3. But what we're doing here is we're just going to find the new value that was 7. It's going to be a new number. So we just stick in the x and the y in the right positions. 2 times 1, 3 times 5 equals b. 2 plus 15 equals b. b equals 17. So the new line is 2x plus 3y equals 17. Now 17 is not the y-intercept. Not the y-intercept. The actual y-intercept would be 17 on 3. But we're not worrying about that. The question is just find the equation of the line. But 17, and the same with 7, 7 is not the y-intercept because y has a coefficient. So copy that in, and when you're ready, come to the next slide. Okay, so now we're finding equations of lines perpendicular, and again passing through some point. So what I did is I found out the first gradient is just 2, and then the second gradient has to be the reciprocal. So because m1 times m2 equals -1 for perpendicular lines, all we do is we just turn 2 upside down and change the sign, and when you multiply those two numbers you get -1. So that means that the equation must be of the form y equals -1/2x plus something, the new y-intercept. Just like we do with parallel lines, we just put the values in of y and x. Don't forget that the first value is the x and the second value is the y, and don't be making mistakes with 2 minuses, make a plus, and then the 3 goes across the other side, becomes a -3, end up with -1, so the new line is -1/2x minus 1. Okay, so that's in gradient intercept form. If by chance you had to give the answer in general form, then 2's no good. You have to get rid of all the fractions. So 2y equals -x minus 2, doubling everything. And in general form, x has to be positive, so move that across. So x plus 2y equals -2. Now you don't do that unless the question says answer in general form. So general form, no fractions, and x has to be positive. Okay? The other numbers, the y and the other number can be negative. But that answer there is okay if it doesn't specify. So again, copy that down, and when you're ready, come to the next slide. And the last one we're doing is equation of a line perpendicular when the equation is given in general form. Now I'm going to show you two methods, and I'm going to show you the long slow method that I used to do all the time, but there's a nice quick method. So the first method is take the equation and rearrange. So take y has to be isolated, so we have to take 4y across the first time, and 1 has to go back. We're trying to isolate 4y, so 4y becomes positive, x hasn't moved, 1's negative, and then divide through by 4 to get rid of the 4 in front. We need to isolate, and strictly speaking I've made a mistake there, so that should be minus a quarter. That doesn't matter because we're just trying to find the gradients. Okay, so the first gradient is staring at you, it's the 3/4, and then to find the second gradient, take the reciprocal of 3/4 and change the sign, so you get minus 4/3. And so the new line must be of the form of that, and that's what we have to find. Find the value of b. So again, it's the same questions. Plug it in, make sure you don't make any mistakes. You're trying to isolate the b, so get rid of the minus 8 to make a plus 8. Find the value of b, so the new line is this. Now again, just in case you have to find general form, 3 is no good, so multiply by 3, which gets rid of the denominator, multiply by 3, 3 9s are 27, and then x is negative, so make that come across the other side, make it a plus, so 4x is positive, 3y hasn't moved, 27 didn't move, so that's in general form. Now that's the way I would have done it heaps and heaps of times, but there's a nice neat trick that you might want to use. So the first equation is of the form 3x minus 4y equals 1, and because the gradient is going to change to reciprocal and change sign, all that's happening is with these 3's and 4's, you just switch them over. So the 4, change colours, so that 4 and that 3, they're going to change positions, and that will give us the reciprocal, and then to change the sign, you just change minus, becomes a plus, and if it was plus it would become a minus. So you change the coefficients because that'll give us the reciprocal, and then you change the signs which will give us the negative reciprocal, and all we have to do is find this new value here, and when you have a look at it, it gives you the same value of 27, which is the same answer, and if you have a look at the setting out, it's really quick. Okay, so there'll be questions in the textbook to do with parallel and perpendicular, so have a go when you can.